Hello, and I would like to welcome you all to the course AWS Tutorial for Certified Cloud Practitioner exam. This course will go through all of the objectives and will cover everything you need to know in order to pass AWS Certified Cloud Practitioner exam. We will start this course by briefly describing the exam itself. The AWS Certified Cloud Practitioner exam is an entry-level certificate for starting your AWS journey and is intended for individuals who have the knowledge, skills, and abilities to demonstrate the basic knowledge of the AWS platform, including available services and their common use cases, AWS Cloud architectural principles, account security, and compliance. The candidate will also demonstrate an understanding of AWS Cloud economics, including costs, billing, analysis, and the value proposition of the AWS Cloud. As a recommended knowledge, candidates should have a basic understanding of IT services. Regarding the exam content, you will run into two types of questions on the exam. Multiple choice questions, where you have one correct answer, and the second type is multiple response question, where you have to select multiple correct answers. Good thing to note is that you have no penalty for guessing the question wrong. Passing score for AWS Cloud Practitioner exam is 70% or 700 points out of 1000. Exam is divided into 4 domains. First one is Cloud Concepts, where we will talk about AWS Cloud and concepts that relate to it. Second, we will talk about security and compliance within AWS Cloud. Then in Technology domain, we will talk about AWS Global Infrastructure and core services that are available, and finish with Billing and Pricing domain, discussing various pricing models that exist in AWS. To wrap this video up, I'd like to show you the web page where you can access more information regarding the exam. So on your favorite browser, you would go to aws.amazon.com, then scroll down. On the bottom of the side you will see Training and Certification. You would go there. On the right hand side there is AWS Certification. Go to Certification Overview. Then click on the Cloud Practitioner that we're now working on. And basically from this page you can download the guides and sample questions, as well as read more about the exam. With that, we conclude the information about the exam, and next we will start getting familiar with the AWS Cloud. Thank you for your time, and looking forward to seeing you in the next video.
In this lesson, we will start with Introduction to AWS Cloud Computing. But before we jump into AWS Cloud Computing and how it is done, we have to take a look at how traditional on-premise infrastructure was planned and designed before there even was a term cloud. So let's say you have created a company and wanted to make an application and wanted to be able to present it to the public so they can consume it or access it in any way that you've imagined. In order to do that, you would have to make your own data center and manage it. Here we have an example of how a part of a data center looks like. So in the traditional data center, you would have to buy your own server racks, servers that you would fit in that rack, get networking equipment and connect it all up together, manage power and cooling of everything. Plus also keep in mind that in case anything fails or breaks within your data center, you have to replace it. Also, what is not mentioned is the manpower that is needed for monitoring and keeping the data center up and running, which is something you also have to keep in mind when designing infrastructure. So all of that can rack up the costs pretty quick. And if all of that equipment is underutilized, you're basically paying for what you're not using, and that is definitely something you don't want to do. Then there comes the AWS Cloud Computing Platform. Amazon Web Services, or AWS, is the world's most comprehensive and broadly adopted cloud platform, offering over 175 fully featured services from data centers globally. The platform is developed with a combination of infrastructure as a service, platform as a service, and packaged software as a service offerings. AWS offers compute power, database storage, content delivery, and other functionality to keep businesses scale and grow. With AWS, you only pay for what you use and without requiring long-term contracts or complex licensing. AWS pricing is similar to how you pay for utilities like water and electricity. You only pay for the services you consume, and once you stop using them, there are no additional costs or termination fees. There are many advantages to using AWS, which we will explain later in the course. We'll go through all the core services in AWS, which will help you create, manage, and scale your infrastructure with ease, and all of that from the comfort of your own home or office without any need to visit data centers and do physical labor. That would be it for the introduction to AWS computing. I would like to thank you for your time, and I'm looking forward to seeing you in the next video. In this lesson, we will focus on advantages that using AWS Cloud brings to your organization. Amazon Web Services, or AWS, gives customers access to cloud services at competitive prices with the flexibility to meet their business needs. Whether it's a small startup or a large enterprise, all companies can leverage the features and functionality of AWS to improve performance and increase productivity. Also, considering the expense and complexity of maintaining a traditional data center, it's no wonder that companies are turning to cloud computing as a way to reduce costs, increase efficiencies, and build their business. Cloud computing helps businesses in the following ways: reduces costs and complexity, adjusts capacity on demand, reduces time to market, increases opportunities for innovation, and enhances security. In addition, cloud technologies can be used to deploy solutions quickly and cost-effectively around the world on any device. In some of the previous lessons, we have talked about all the things that you need to keep track of when you have your own data center. When you decouple from the data center, you will be able to do many things differently. Decrease your TCO, TCO is total cost of ownership, or eliminate many of the costs related to building and maintaining a data center or colocation deployment. So pay for only the resources you consume. Reduce complexity or reduce the need to manage infrastructure, investigate licensing issues, or divert resources. Adjust capacity on the fly. That means that you can add or reduce resources depending on seasonal business needs, using infrastructure that is secure, reliable, and broadly accessible. Reduce time to market. That means you'll be able to design and develop new IT projects much faster. Deploy quickly, even worldwide, or deploy applications across multiple geographic areas. Increase efficiencies. Use automation to reduce or eliminate IT management activities that waste time and resources. Innovate more, meaning spin up a new server and try out an idea. Each project moves through the funnel more quickly because the cloud makes it faster and cheaper to deploy, test, and launch new products and services. Spend your resources strategically. Switch to a DevOps model to free your IT staff from operations and maintenance that can be handled by the cloud service provider. And enhance security, which means spend less time conducting security reviews on infrastructure. Mature cloud providers have teams of people who focus on security, offering best practices to ensure you're compliant no matter what your industry, and we will talk about security more in depth later on in the course. Those were some of the main advantages to moving to the cloud. The barriers to entry are significantly reduced too. Many companies find that costs of cloud computing are so low they can move as much or as little of their environment to the cloud without having to make a business case to pursue an idea. And of course, moving to the cloud doesn't have to be a binary proposition. You can move as much or as little of your infrastructure to the cloud as suits your business. For example, many AWS customers start with a small pilot project and develop their cloud use as business needs dictate. To get to know how AWS Cloud is able to provide much lower costs than managing your own data center, and in the same time offers a quality of service that is unmatched, we have to take a look at AWS economics. The AWS infrastructure serves millions of active customers in over 190 countries and offers the following benefits to its users. Global operations. AWS operates across 6 continents, offering multiple availability zones in each of the 11 geographic areas known as regions. To achieve the greatest possible fault tolerance and stability, AWS isolates regions from one another. You can put your resources in multiple locations to reduce latency and improve performance. Resources aren't replicated across regions unless you choose to do so. High availability. AWS operates state-of-the-art, highly available data centers. Although rare, failures that affect the availability of instances in the same location can occur. If you host all of your instances in a single location that is affected by such a failure, none of your instances will be available. For that reason, you may choose to replicate data in different availability zones to ensure a swift recovery in case of disaster. Low costs due to high volume. The scale and operations of AWS support lower costs and higher efficiencies than those in most on-premises data centers. These efficiencies are a result of overall supply chain optimization, high level of automation, and volume-based purchasing. Only pay for what you use. AWS allows users to consume only the services you need for as long as you need them and with no complex agreements or licensing dependencies. There are no termination clauses or hidden fees. Economies of scale. AWS has developed hardware and software that is optimized for large-scale clouds by acquiring manufacturers of customer servers and Netgear, delivering capabilities required for large-scale deployments. Similarly, through direct purchase of disk, memory, and CPU, AWS can drive economies of scale that are otherwise difficult to replicate. Financial flexibility. AWS helps customers reduce large capital investments with lower variable costs. AWS also gives customers the opportunity to work on their own terms without long-term lock-in, reducing the risk from unplanned capacity and demand. AWS helps finance teams plan and forecast more efficiently, while giving IT teams the capacity and resources they need even during peak periods. AWS offers few pricing models, which we will all discuss later on in the course. Now, to verify all of these benefits using AWS Cloud, you can read many articles on large companies leveraging AWS Cloud solution to run and enhance their business. And also AWS has a page where you can read case studies and see for yourself how many companies have utilized power of AWS Cloud. If you switch to your browser and go to aws.amazon.com/solutions/case studies, you will get the page where you can read all of that. There are some pretty big names in the industry that you can definitely learn something from. This will conclude the lesson on advantages of AWS Cloud Computing. I would like to thank you for your time, and I'm looking forward to seeing you in the next video. In this lesson, we will take a look at Amazon Web Services free tier offerings. So, what is AWS free tier exactly? The AWS free tier is automatically activated on each new AWS account. The AWS free tier lasts for 1 year. While the AWS free tier is active, you can try many AWS services for free. However, not all AWS services are free. You're responsible for any charges you incur while using AWS services. You must also constantly monitor your usage to make sure that you're not exceeding the limitations covered under the free tier. There are 3 types of offerings that are available with the free tier: always free, 12 months free, and trials, and we will explain every one of them. First, we will start with always free. Always free means that these free tier offers do not automatically expire at the end of your 12-month AWS free tier term, but are available to both existing and new AWS customers indefinitely. Example of these services would be Amazon DynamoDB, AWS Lambda, Amazon SNS, and CloudWatch, to name the few most popular. Next, we have 12-month AWS services. These free tier offers are only available to new AWS customers and are available for 12 months following your AWS sign-up date. When your 12 months free usage term expires, or if your application use exceeds the tiers, you simply pay standard pay-as-you-go service rates. Example of these services, and the most popular used by anyone that is starting their AWS cloud journey, is definitely Amazon EC2, which is a compute capacity or virtual machines in the AWS cloud. Other examples would include Amazon S3 and Amazon RDS. The last one of free tier offerings is trials. These free tier offers are short-term trial offers that start from the time of first usage begins. Once the trial period expires, you simply pay standard pay-as-you-go service rates. Some services among the trial offers are Amazon SageMaker, which is a machine learning service provided by AWS, and Amazon Lightsail, which is one of the compute services. We will now go to AWS website and see the section that is regarding AWS free tier that we have just talked about. So in your browser, navigate to aws.amazon.com/free, and you will see the page about AWS free tier offerings. You can see types of offers that we discussed previously: always free, 12 months free, and trials. If you scroll further down the page, you will see the services that we have mentioned, and you can filter by the types and categories. So let's filter by the first thing, and that's always free. So, for example, we see familiar services like Amazon DB, AWS Lambda, and Amazon SNS. If you hover over any of those services, you will see more information about it and what free tier actually offers for this service. Amazon DynamoDB is fast and flexible NoSQL database with seamless scalability, and with free tier you get 25 gigabytes of storage, some write and read capacity units as well. Then we have AWS Lambda, which is a way for you to run your code without the need to provision servers, a so-called serverless model. With AWS Lambda, for example, you get 1 million requests per month for free, which is really great. So let's go now to 12 months free services. And first of all, we see Amazon EC2, which is a resizable compute capacity in the cloud. So with AWS free tier, you can spin up your virtual machine. It is free for 750 hours per month, which is just enough to have it running whole month without you shutting it down at all. Bear in mind, there are some limitations to sizes of those machines, as stated in the description. Another popular service is Amazon S3, which is secure, durable, and scalable object storage infrastructure. And with free tier, you get 5 gigabytes of standard storage per month. Let's just mention Amazon AWS RDS here as well, which is Managed Relational Database Service for MySQL, PostgreSQL, Maria Database, Oracle Bring Your Own License, or SQL Server. And you can have that for 750 hours per month as well, as you also get some storage space to go with that, which is nice. We'll finish off this with trials. So, and mention Amazon fully managed platform to build, train, and deploy machine learning models, and Amazon Lightsail, which is a form of virtual private servers, and you can see that you have a free 1 month trial with that. We have only talked about few services that are available within AWS free tier. There are plenty of more there. Make sure to check this page and to know more about those and what you can use and play with, test and development environments and such. That would be it for this lesson on AWS free tier. I would like to thank you for your time, and I'm looking forward to seeing you in the next video. In this lesson, we will talk about design principles of AWS cloud computing architecture. AWS has developed something called the well-architected framework to help cloud architects build the most secure, high-performing, resilient, and efficient infrastructure possible for their applications. This framework provides a consistent approach for customers and partners to evaluate architectures and provide guidance to help implement designs that will scale with your application needs over time. The AWS well-architected framework is based on 5 pillars, and that's security, reliability, performance efficiency, cost optimization, and operational excellence, and we will explain them all. First, we will start with security. Security means the ability to protect information, systems, and assets while delivering business value through risk assessments and mitigation strategies. The security pillar focuses on protecting information and systems. Key topics include confidentiality and integrity of data, identifying and managing who can do what with privilege management, protecting systems, and establishing controls to detect security events. To strengthen security of a system and protect it from critical threats and vulnerabilities, AWS suggests following design principles. Implement a strong identity foundation, enable traceability, apply security at all layers, protect data in transit and at rest, keep people away from data, automate security best practices, and prepare for security events. Next, we have reliability, or the ability of a system to recover from infrastructure or service failures, dynamically acquire computing resources to meet demand, and mitigate disruptions such as misconfiguration or transient network issues. The reliability pillar focuses on the availability to prevent and quickly recover from failures to meet business and customer demand. Key topics include foundational elements around setup, cross-project requirements, recovery planning, and how we handle change. The well-architected framework suggests following design principles regarding reliability. Test recovery procedures, automatically recover from failure, use horizontal scalability to increase your system availability, stop guessing capacity, and manage change in automation. Next one, we have performance efficiency, which is the ability to use compute resources efficiently to meet system requirements and to maintain that efficiency as demand changes and technologies evolve. The performance efficiency pillar focuses on using IT and computing resources efficiently. Key topics include selecting the right resource types and size based on workload requirements, monitoring performance, and making informed decisions to maintain efficiency as business needs evolve. The design principles recommended are democratize advanced technologies, deploy your systems globally at minimal cost for lower latency, use serverless architecture to avoid operational burden, try various comparative testing and configurations to find out what performs better, and last, to experiment more often. Next pillar we have is cost optimization, or the ability to avoid or eliminate unneeded cost or suboptimal resources. Cost optimization focuses on avoiding unnecessary costs. Key topics include understanding and controlling where money is being spent, selecting the most appropriate and right number of resource types, analyzing spend over time, and scaling to meet business needs without overspending. All of this can be achieved by the following principles. Adopt a consumption model, measure overall efficiency, stop spending money on data center operations, analyze and attribute expenditure, and last one is use managed services to reduce cost of ownership. Last pillar that we'll mention in this course is operational excellence, which is defined as the ability to run and monitor systems to deliver business value and to continually improve supporting processes and procedures. The operational excellence pillar focuses on running and monitoring systems to deliver business value and continually improving processes and procedures. Key topics include managing and automating changes, responding to events, and defining standards to successfully manage daily operations. AWS suggests 6 principles which will help drive the operational excellence, and that is perform operations with code, annotate documentation, make frequent small reversible changes, refine operations procedures frequently, learn from operating events and failures, and anticipate failure. Now, if you want to learn more and read about AWS well-architected framework pillars, AWS has published many white papers where they in great depth explain each and every pillar, and that's something you definitely will find useful if you architecture any type of infrastructure on AWS. This will conclude the lesson on design principles of AWS Cloud Computing Architecture. I would like to thank you for your time, and I'm looking forward to seeing you in the next video. This lesson is about AWS Shared Responsibility Model. We will talk what it is and what does it include. So security and compliance is a shared responsibility between AWS and the customer. This shared model can help relieve the customer's operational burden as AWS operates, manages, and controls the components from the host operating system and virtualization layer down to the physical security of the facilities in which the services operates. The customer assumes responsibility and management of the guest operating system, including updates and security patches, other associated application software, as well as the configuration of the AWS-provided security group firewall. Customers should carefully consider the services they choose, as their responsibilities vary depending on the services used, the integration of those services into their IT environments, and applicable laws and regulations. The nature of their shared responsibility also provides the flexibility and customer control that permits the deployment. This differentiation of responsibility is commonly referred to as security of the cloud versus security in the cloud. So on the next slide here, we see the chart that shows what is security of the cloud versus security in the cloud, and we will explain this now in the next slides as well. First, we'll talk about AWS responsibility or security of the cloud. AWS is responsible for protecting the infrastructure that runs on the services offered in the AWS cloud. This infrastructure is composed of hardware, software, networking, and facilities that run AWS cloud services. Next, we have customer responsibility or security in the cloud. So customer responsibility will be determined by the AWS cloud services that the customer selects. This determines the amount of configuration work the customer must perform as a part of their security responsibilities. For example, a service such as Amazon Elastic Compute Cloud or Amazon EC2 is categorized as infrastructure as a service, and as such requires the customer to perform all the necessary security configuration and management tasks. Customers that deploy Amazon EC2 instance are responsible for management of the guest operating system, including updates and security patches, any application software or utilities installed by customer on the instances, and the configuration of the AWS provided firewall, which is called the security group on each instance. For abstracted services, such as Amazon S3 and Amazon DynamoDB that we mentioned in previous lessons, AWS operates the infrastructure layer, the operating system and platforms, and customers access the endpoints, store and retrieve data. Customers are responsible for managing their data, including encryption options, classifying their assets, and using identity and access management tools to apply the appropriate permissions. This customer / AWS shared responsibility model also extends to IT controls. Just as the responsibility to operate the IT environment is shared between AWS and its customers, so is the management, operation, and verification of IT controls shared. AWS can help relieve customer burden of operating controls by managing those controls associated with physical infrastructure deployed in the AWS environment that may previously have been managed by the customer. As every customer is deployed differently in AWS, customers can take advantage of shifting management of certain IT controls to AWS, which can result in a new distributed control environment. Customers can then use the AWS control and compliance documentation available to them to perform their control evaluation and verification procedures as required. Below are the examples of controls that are managed by AWS, AWS customers, and or both. So first we have inherited controls, or controls which a customer fully inherits from AWS, and the example includes physical and environmental controls as stated previously in the lesson. Then we have shared control, or controls which apply to both the infrastructure layer and customer layers, but in completely separate context or perspectives. In a shared control, AWS provides the requirements for the infrastructure, and the customer must provide their own control implementation within their use of AWS services. Examples would include patch management. AWS is responsible for patching and fixing flaws within the infrastructure, but customers are responsible for patching their guest OS and applications. Configuration management. AWS maintains the configuration of its infrastructure devices, but a customer is responsible for configuring their own guest operating system, databases, and application. And the last example would be awareness and training. So AWS trains AWS employees, of course, but a customer must train their own employees. Then we have customer-specific controls, or controls which are solely the responsibility of the customer based on the application they're deploying within AWS services. Examples include service and communication protection, or zone security, which may require a customer to route or zone data within specific security environments. This will conclude the lesson on AWS Shared Responsibility Model. I would like to thank you for your time, and I'm looking forward to seeing you in the next video. The topic of this lesson is Introduction to Security and Compliance in AWS Cloud. So, cloud security at AWS is the highest priority. As an AWS customer, you will benefit from a data center and network architecture built to meet the requirements of the most security-sensitive organizations. Security in the cloud is much like security in your on-premises data centers, only without the costs of maintaining facilities and hardware. In the cloud, you don't have to manage physical servers or storage devices. Instead, you use software-based security tools to monitor and protect the flow of information into and out of your cloud resources. An advantage of the AWS Cloud is that it allows you to scale and innovate while maintaining a secure environment and paying only for the services you use. This means that you can have the security you need at a lower cost than in an on-premises environment. As mentioned in the previous lesson, the AWS Cloud enables a shared responsibility model. While AWS manages security of the cloud, you are responsible for security in the cloud. This means that you retain control of the security you choose to implement to protect your own content, platform, applications, systems, and network, no differently than you would in an on-site data center. AWS provides you with guidance and expertise through online resources, personnel, and partners. AWS provides you with advisories for current issues, plus you have the opportunity to work with AWS when you encounter security issues. You get access to hundreds of tools and features to help you meet your security objectives. AWS provides security-specific tools and features across network security, configuration management, access tools, and data encryption. Also, AWS environments are continuously audited with certification from accreditation bodies across geographies and verticals. In the AWS environment, you can take advantage of automated tools for asset inventory and privileged access reporting. Speaking of benefits, there are many benefits of AWS security. To name a few, keep your data safe. So the AWS infrastructure puts strong safeguards in place to help protect your privacy. All data is stored in highly secure AWS data centers. Meet compliance requirements. AWS manages dozens of compliance programs in its infrastructure. This means that segments of your compliance have already been completed. Save money. This means cut costs by using AWS data centers. maintain the highest standard of security without having to manage your own facility. And the last one we'll mention, scale quickly. Security scales with your AWS cloud usage. So no matter the size of your business, the AWS infrastructure is designed to keep your data safe. Now, how is AWS security actually implemented? We'll name a few examples of it. First example is infrastructure security, and that includes network firewalls built into Amazon VPC or virtual private cloud, which you can use, and those are called security groups. In-transit encryption using TLS across all services means that your communication is encrypted and safe from third parties. And last example, we mentioned private or dedicated connections into your data center, but using AWS VPN solutions. Next example, we have data encryption. So at-rest encryption is available in various AWS solutions such as EBS, S3, Glacier, and RDS. Key management through AWS KMS. You can choose whether to control the keys or let AWS do that for you. Dedicated hardware-based cryptographic key storage using AWS Cloud HSM service. And we have APIs to integrate AWS security into any applications you create. Then we have AWS monitoring and logging solutions in the shape of AWS CloudTrail, where we have deep visibility into API calls, including who, what, when, and from where calls were made. Log aggregation options, alert notifications through Amazon CloudWatch when specific events occur or thresholds are exceeded. Of course, AWS had built-in identity and access control solution called AWS Identity and Access Management, or IAM, that lets you define individual user accounts with permissions across AWS resources. AWS multi-factor authentication for privileged accounts, and many, many more. So AWS cloud compliance enables you to understand the robust controls in place at AWS to maintain security and data protection in the cloud. So as systems are built on top of AWS cloud infrastructure, compliance responsibilities are shared. By tying together governance-focused, audit-friendly service features with applicable compliance or audit standards, AWS compliance enables to build on traditional programs. This helps customers to establish and operate in AWS security control environment. The IT infrastructure that AWS provides to its customers is designed and managed in alignment with the best security practices and the variety of IT security standards. And here on the right hand side, we can see some assurance programs with which AWS complies. And there we have SOC compliance, the HIPAA, PCI DSS as well, and many, many more. AWS also provides customers a wide range of information on its IT control environment in white papers, reports, certification accreditations, and other third-party attestations. This concludes the lesson on security and compliance in AWS Cloud. I would like to thank you for your time, and I'm looking forward to seeing you in the next video. In this lesson, we will talk about AWS Access Management. So, what is AWS Identity and Access Management? AWS Identity and Access Management, or IAM for short, enables you to manage access to AWS services and resources securely. Using IAM, you can create and manage AWS users and groups and use permissions to allow and deny their access to AWS resources. IAM is a feature of your AWS account offered at no additional charge. You will be charged only for use of any other AWS services by your users. IAM allows you to manage IAM users and their access. You can create users in IAM, assign them individual security credentials, in other words, access keys, passwords, and multi-factor authentication devices, or request temporary security credentials to provide users access to AWS services and resources. You can manage permissions in order to control which operations a user can perform. You can also manage IAM roles and their permissions. So you can create roles in IAM and manage permissions to control which operations can be performed by the entity or AWS service that assumes the role. You can also define which entity is allowed to assume the role. In addition, you can use service-linked roles to delegate permissions to AWS services that create and manage AWS resources on your behalf. Last one is manage federated users and their permissions. You can enable identity federation to allow existing identities, users groups or roles in your enterprise to access the AWS Management Console, call AWS APIs and access resources without the need to create an IAM user for each identity. So IAM at Amazon Web Services offer you the following features. First, shared access to your AWS account. Without sharing your password, you're eligible to access the other permission with respect to the administrator as well as the resources from your current AWS account. Second is granular permissions. So by using this granular permission, you're able to grant permissions for different according to their resources. By considering an example, you can give the whole access to Amazon EC2, S3, as well as to remaining AWS services. While the other users can allow getting the read-only access along with the administrator EC2 instances in order to access the process of billing information. Secured access to AWS sources. This IAM feature at AWS will be used to secure all the login credentials which can successfully on the EC2 instances. You can also offer them the permission in order to access your application with respect to AWS services. Multi-factor authentication or MFA. By using the MFA, you can easily add the two-factor authentication, not only for your account, but also for the individual users for more security. Either you or your user can provide an access key or password in order to work with your account with the help of a code which is specifically configured by the device. Identity federation. The identity federation at IAM will allow the users who already have their passwords. For example, let's consider an ex-corporate network or else an internet provider in order to get temporary access to your current AWS account. Then we have identity information for assurance. If you're using CloudTrail option for your AWS account, then you will definitely get the log records, which contains all the information that is made according to the resources in your account. All those information generally named as the IAM identities. And the last one is PCI DSS compliance. The IAM at AWS will completely support all storage, transmission, storage of the data by both provider and merchant in order to validate the compliance with PCI, so the payment card industry data security standard, or PCI DSS for short. Next session of the lesson, we will focus on IAM identities, which are created to provide authentication for people and processes in your AWS account. This section also describes IAM groups, which are a collection of IAM users that you can manage as a unit. Identities represent the user and can be authenticated and then authorized to perform actions in AWS. Each of these can be associated with one or more policies to determine what actions a user, role, or member of a group can do with which AWS resources and under what conditions. So when you first create an Amazon Web Services account, you begin with a single sign-in identity that has complete access to all AWS services and resources in the account. And this identity is called the AWS account root user and is accessed by signing in with the email address and password that you used to create the account. Generally, it is strongly recommended that you do not use the root user for your everyday tasks, even the administrative ones. Instead, adhere to the best practice of using the root user only to create your first IAM user, then securely lock away the root user credentials and use them to perform only a few account and service management tasks. So we have IAM users. An IAM user is an identity that you create in AWS. The IAM user represents the person or service who uses the IAM user to interact with AWS. Primary use for IAM users is to give people the ability to sign into the AWS Management Console for interactive tasks and to make programmatic requests to AWS services using the API or CLI. An user in AWS consists of a name, a password to sign into the AWS Management Console, and up to 2 access keys that can be used with the API or CLI. So when you create an IAM user, you grant it permissions by making it a member of a group that has appropriate permission policies attached, or by directly attaching policies to the user. Next we have IAM group. IAM group is a collection of IAM users, and you can use groups to specify permissions for a collection of users, which can make those permissions easier to manage for those users. For example, you could have a group called admins and give that group the types of permissions that administrators typically need. Any user in that group automatically has the permissions that are assigned to the group. And if a new user joins, for example, your organization and should have the administrator privileges, you can assign the appropriate permissions by just adding the user to that group. Similarly, if a person changes a job in your organization, instead of editing that user's permission, you can remove him or her from the old groups and add him or her to the appropriate new groups. And last, we have IAM roles. An IAM role is very similar to a user in that it is an identity with permission policies that determine what the identity can and cannot do in AWS. However, a role does not have any credentials, that be password or access keys, associated with it. Instead of being uniquely associated with one person, a role is intended to be assumable by anyone who needs it. An IAM user can assume a role to temporarily take on different permissions for specific tasks, for example. Now, with AWS, as any AWS service, there are AWS IAM best practices that helps to perform certain relative audits and make sure that your AWS account is as secure as possible. And those best practices include to lock away the AWS account root user access keys, creation of individual IAM users, use AWS defined policies for assigning the permissions if required, usage of certain groups to assign permissions to IAM users, grant least privilege, usage of access levels to review IAM permissions, and the configuration of strong password policy for users. This concludes the lesson on AWS Access Management. I would like to thank you for your time, and I'm looking forward to seeing you in the next video. While using AWS Identity and Access Management Service, it is good to know that there are things that are out there to help you guide you through the setup and provide support if you get stuck somewhere. We will briefly go over these things. First, we have AWS support. AWS support provides tools and resources to help you make sure your AWS environment is built and operated to be secure, highly available, efficient, and cost-effective. With a focus on the security and operational health of your infrastructure, AWS support provides real-time insight through AWS Trusted Advisor. Trusted Advisor is an online tool that serves as your customized cloud expert and helps you provision your resources by following best practices. Trusted Advisor inspects your AWS environment and finds opportunities to save money, improve system performance and reliability, or help close security gaps. Proactive support and advocacy through Technical Account Manager or TAM. So your TAM is your single point of contact and advocate who provides technical expertise across the full range of AWS services. TAMs work closely with you to deliver proactive guidance, and early awareness of new features and recommendations. And should you have any unplanned issues, your TAM ensures that they are resolved as swiftly as possible. The full range of AWS Trusted Advisor checks is available to all customers with business and enterprise level support, and technical account managers are included with enterprise support. Other than that, we also have professional services. So AWS Professional Services and the AWS Partner Network can help you create more comprehensive solutions to security problems. Everything from including strategic advice, deployments, to re-engineering your security processes. Example engagements would include enterprise security architecture, or evaluate the nature of the workloads you're deploying in AWS, along with your security needs, and define an architecture and set of security controls that will protect your data and workloads according to best practices. Then we have policies and controls mapping. Examine your requirements based upon your security policy and any third-party or regulatory mandates, and provide detailed recommendations on how to satisfy those requirements and demonstrate compliance. Security operations playbook, that means to define the right organizational structures and processes to ensure that security controls are working correctly, as well as detect and respond to security issues that arise within your AWS environment. And last one is business unit workshops. So work with IT and business leaders across your organization to understand their plans and strategies around cloud adoption, educate them on the best way to satisfy their requirements while minimizing risk to the organization, and devise an organization-wide security framework for deploying workloads on AWS. As always, you can learn more about this by visiting AWS website and researching various white papers on the subjects that you're interested in. That would be all for the lesson on AWS security support resources. I would like to thank you for your time, and I'm looking forward to seeing you in the next video. Now we will introduce ourselves to ways and methods of deploying and operating in AWS Cloud. Amazon Web Services offers multiple options for provisioning your IT infrastructure and the deployment of your applications. Whether it's a simple three-tier application or a complex set of workloads, the deployment model varies from customer to customer. But with the right techniques, AWS can help you pick the best strategy and tool set for deploying an infrastructure that can handle your workload. We will focus first on a couple of AWS solutions, and then we will also mention non-AWS solutions which can be used to achieve the same or pretty close to the same things. Major AWS solutions that can be used are AWS Elastic Beanstalk, AWS CloudFormation, AWS OpsWorks, AWS Cloud Commit, AWS Code Pipeline, AWS Code Deploy, and Amazon Elastic Container Service. Now, first we will start with mentioning a service called AWS Elastic Beanstalk. So Elastic Beanstalk is a high-level deployment tool that you can get an app from your desktop to the web in a matter of minutes. Elastic Beanstalk handles the details of your hosting environment, so capacity provisioning, load balancing, scaling, and application health monitoring, so you don't have to. A platform configuration defines the infrastructure and software stack to be used for a given environment. When you deploy your app, Elastic Beanstalk provisions a set of AWS resources that can include Amazon EC2 instances, alarms, load balancer, security groups, and more. Next, we have AWS CloudFormation. AWS CloudFormation is a service that helps you model and set up your Amazon Web Services resources so that you can spend less time managing those resources and more time focusing on your applications that run in AWS. You can create a template that describes the AWS resources that you want. For example, Amazon EC2 instances or Amazon RDS DB instances, and AWS CloudFormation takes care of provisioning and configuring those resources for you. Then we have AWS OpsWorks. AWS OpsWorks is a configuration management service that helps you configure and operate applications in a cloud enterprise by using Chef. There are two variants to it, AWS OpsWorks Stacks and AWS OpsWorks for Chef Automate. Now, AWS OpsWorks Stacks, the original service, provides a simple and flexible way to create and manage stacks and applications. AWS OpsWorks Stacks lets you deploy and monitor applications in your stacks. Unlike AWS OpsWorks for Chef Automate, AWS OpsWorks Stacks does not require or create Chef servers. It performs some of the work of a Chef server for you. AWS OpsWorks Stacks monitors instance health and provisions new instances for you when necessary by using auto-healing and auto-scaling. It also lets you create AWS managed Chef servers that include Chef Automate premium features and use the Chef DK and other Chef tooling to manage them. AWS OpsWorks for Chef Automate manages both Chef Automate server and Chef server software on a single instance. Next, we will move to AWS Cloud Commit. AWS Code Commit is a fully managed source control service that makes it easy for companies to host secure and highly scalable private Git repositories. Code Commit integrates with AWS Code Pipeline and AWS Code Deploy to streamline your development and release process, and we will explain these two as well now. So moving to AWS Code Pipeline, it is a continuous integration and continuous delivery service for fast and reliable application and infrastructure updates. Code Pipeline builds, tests, and deploys your code every time there is a code change based on the release process model that you define. AWS Code Deploy is a service that automates code deployments and software deployments to any instance, including Amazon EC2 instances and instances running on premises as well. AWS Code Deploy makes it easy for you to rapidly release new features, helps you avoid downtime during application deployment, and handles the complexity of updating your applications. Now, last AWS service that we will talk about in this lesson is Amazon Elastic Container Service, or ECS. Amazon Elastic Container Service is a highly scalable, high-performance container management service that supports Docker containers and allows you to easily run applications on a managed cluster of Amazon EC2 instances. Amazon ECS eliminates the need for you to install, operate, and scale your own cluster management infrastructure. Now, there are non-AWS solutions as well, which can help you deploy and operate within your AWS cloud environment. We can divide them by things they're used for. Starting with infrastructure as code, you can use tools like Terraform and SaltStack. For configuration management, industry standard tools like Chef, for example, Puppet and Ansible, all can be used in AWS as well. Speaking of CI or continuous integration tools, you can use a variety of tools like Jenkins, TeamCity, to name a few. When we talk about best practices regarding deploying and operating in AWS Cloud, you should follow these principles if you don't want to run into any problems later on in the projects, and it's definitely something that should be implemented from the start. So some of these tips would include provision infrastructure from code, deploy artifacts automatically from version control, configuration managed from code and applied automatically, scale your infrastructure automatically, monitor every aspect of the pipeline and the infrastructure. You can use CloudWatch for that, for example. Next one is logging for every action, and for that you can use AWS CloudWatch logs and AWS CloudTrail as well. Then we have instance profiles for embedding IAM roles in instances automatically. Use variables, don't hard code any values in your code. And also tagging can be used with automation to provide more insights on what has been provisioned. So once you deploy your infrastructure, there of course will be changes to code or infrastructure, and you want to be able to do these updates in a correct fashion. You can do this by following these advices. You can update your Amazon machine images or AMIs and then deploy a new environment from them. You can also use CI tools to deploy the code to existing environments. You can use the blue-green method to have one environment for production, that's blue, and one for the new version, or green. And when it is time to upgrade, simply redirect the traffic from blue to green. Follow all these suggestions and your AWS Cloud journey should be without much troubles once you set it up correctly. That would be all for the lesson on deploying and operating in AWS Cloud. I would like to thank you for your time, and I'm looking forward to seeing you in the next video. In this lesson, we will talk about AWS Global Infrastructure. The AWS Global Cloud Infrastructure is the most secure, extensive, and reliable cloud platform, offering over 175 fully featured services from data centers globally. Whether you need to deploy your application workloads across the globe in a single click, or you want to build and deploy specific applications closer to your end users with single-digit millisecond latency, AWS provides you the cloud infrastructure where and when you need it. With millions of active customers and tens of thousands of partners globally, AWS has the largest and most dynamic ecosystem. Customers across virtually every industry and of every size, including startups, enterprises, and public sector organizations, are running every imaginable use case on AWS. So AWS now spans 76 availability zones within 24 geographic regions around the world, and has announced plans for 9 more availability zones and 3 more AWS regions in Indonesia, Japan, and Spain. Here on this picture we can see all of the AWS regions and also ones that are in plan and are coming soon. So moving on, AWS Cloud Infrastructure is built around regions and availability zones, also known as AZs for short. So a region is a physical location in the world with multiple AZs. Availability zones consist of one or more discrete data centers, each with redundant power and networking, housed in separate facilities that are located on stable fluid planes. These availability zones offer the abilities to operate production applications and databases which are highly available, fault tolerant, and scalable than it will be possible from a single data center. Unlike virtually every other technology infrastructure provider, each AWS region has multiple availability zones and data centers. Customers who care about the availability and performance of their applications want to deploy these applications across multiple availability zones in the same region for fault tolerance and low latency. Availability zones are connected to each other with fast and private fiber optic network, which enables applications to automatically fail over basically between availability zones without any interruption. In addition to replicating applications and data across multiple data centers in the same region using availability zones, you can also choose to further increase redundancy and fault tolerance by replicating data between geographic regions. You can do so using both private and public network to provide an additional layer of business continuity, or to provide low latency access across the globe. You retain complete control over ownership of the region in which your data is physically located, making it easy to meet regional compliance and data residency requirements. Next thing we will mention is AWS Edge Locations. So Edge Locations are AWS sites deployed in major cities and highly populated areas across the globe. They far outnumber the number of availability zones available, And while edge locations are not used to deploy your main infrastructures, such as EC2 instances, EBS storage, VPCs, or RDS resources like availability zones do, they're used by AWS services such as AWS CloudFront and AWS Lambda at Edge, for example, to cache data and reduce latency for end user access by using edge locations as a global content delivery network, or CDN. As a result, edge locations are primarily used by end users who are accessing and using your services. For example, you may have your website hosted on EC2 instances and S3, your origin, within the Ohio region with a configured AWS CloudFront distribution associated. So when a user accesses your website from Europe, they would be redirected to their closest edge location, which is in Europe, where cache data could be read on your website, and that would significantly reduce the latency for end user. Now, there are several benefits to AWS global infrastructure, and we'll name a few of them. First one is security. Security at AWS starts with their core infrastructure, custom built for the cloud and designed to meet the most stringent security requirements in the world. Their infrastructure is monitoring 24/7 to help ensure the confidentiality, integrity, and availability of your data. All data flowing across the AWS global network that interconnects their data centers and regions is automatically encrypted at the physical layer before it even leaves their secure facilities. Next one, we will mention availability. AWS delivers the highest network availability of any cloud provider, with 7 times fewer downtime hours than the next largest cloud provider. Each region is fully isolated and comprised of multiple availability zones, which are fully isolated partitions of our infrastructure. To better isolate any issues and achieve high availability, you can partition applications across multiple AZs in the same region. Then we have performance. The AWS global infrastructure is built for performance. AWS regions offer low latency, low packet loss, and high overall network quality. This is achieved with a fully redundant 100 gigabits fiber network backbone, often providing many terabits of capacity between regions. Then we have a global footprint. AWS has the largest global infrastructure footprint of any provider, and this footprint is constantly increasing at a significant rate. When deploying your applications and workloads to the cloud, you have the flexibility in selecting a technology infrastructure that is closest to your primary target or users. We'll mention also scalability. So the AWS global infrastructure enables companies to be extremely flexible and take advantage of the conceptually infinite scalability of the cloud. Customers used to over-provision to ensure that they had enough capacity to handle their business operations at the peak level of activity, and now they can provision the amount of resources that they actually need, knowing they can instantly scale up or down along with the needs of their business. And last one, we'll mention flexibility. The AWS global infrastructure gives you the flexibility of choosing how and where you want to run your workloads. And when you do, you're using the same network, control plane, APIs, and AWS services. If you'd like to run your applications globally, you can choose from any of the AWS regions and AZs that are available. This will conclude the lesson on AWS Global Infrastructure. I would like to thank you for your time, and I'm looking forward to seeing you in the next video. In this lesson, we will talk about core AWS services. Amazon Web Services, as the largest and most dominant cloud provider in the world, offers a large variety of services spanning many different categories to match the diversity of technical needs in modern cloud-centric development. We can give you an exact number of services that are available, but it is estimated that there are more than 170 services available as of now. Of course, we don't have the time or need to go through them all right now, but it is important to get familiar with some core AWS services, and we will explain them more in depth. And to do so, we will group them in 5 categories. So networking and content delivery, compute, storage, database, and last, management and governance. So you can see the core services there. So in networking section, we'll talk about Amazon VPC, Amazon CloudFront, Amazon Route 53, AWS Private Link, and AWS Direct Connect. Moving on to compute section, I will talk about Amazon EC2 or Elastic Cloud Computing, which we have mentioned in previous lessons, Amazon Elastic Container Services, Amazon Lightsail, AWS Elastic Beanstalk, and AWS Lambda. Moving on to storage section, we will mention Amazon Simple Storage Service or Amazon S3, Amazon Elastic Block Storage or EBS for short, Amazon Elastic File System or EFS, and Amazon S3 Glacier. For database section, we will take a look at Amazon Aurora, Amazon RDS, and Amazon DynamoDB. To wrap it up, we will describe management services with Amazon CloudWatch, AWS CloudTrail, and AWS CloudFormation. So we will describe all of the services mentioned now in the next videos. If you're interested to learn about all the services that AWS offers, go to their webpage and you can see white papers and documentation on all of the services that AWS has to offer, and there really is a lot of them. This will conclude the introduction on AWS core services. In the next video, we'll talk about them. I would like to thank you for your time, and I'm looking forward to seeing you in the next video. In this lesson, we will talk about core AWS services regarding networking and content delivery. As mentioned in the previous lesson, we'll describe Amazon VPC, Amazon CloudFront, Amazon Route 53, AWS Private Link, and AWS Direct Connect. So let's first mention Amazon VPC. Amazon Virtual Private Cloud, or Amazon VPC, lets you provision and logically isolated section of the AWS cloud where you can launch AWS resources in a virtual network that you define. So you have complete control over your virtual networking environment, including selection of your own IP address range, creation of subnets, and configuration of route tables and network gateways. You can use both IPv4 and IPv6 in your VPC for secure and easy access to both resources and applications. You can also easily customize the network configuration for your VPC. For example, you can create a public-facing subnet for your web servers that has access to the internet and place your backend systems, such as databases or application servers, in a private-facing subnet with no internet access. You can also leverage multiple layers of security, including security groups and network access control lists, to help control access to EC2 instances in each subnet. Additionally, you can create a hardware virtual private network or VPN connection between your corporate data center and your VPC, and leverage the AWS cloud as an extension basically of your corporate data center. We will later create our first VPC in the demo and see all of the options that you can configure while doing so. Moving on, Amazon CloudFront is a fast content delivery network or CDN service that securely delivers data, videos, applications, and APIs to customers globally with low latency, high transfer speeds, and all within a developer-friendly environment. CloudFront is integrated with AWS, both physical locations that are directly connected to AWS global infrastructure, as well as other AWS services. CloudFront works seamlessly with services including AWS Shield for DDoS migration or distributed denial of service, Amazon S3 Elastic Load Balancing, or Amazon EC2 as origins for your application, and for example Lambda at Edge to run custom code closer to customers' users and to customize the user experience. You can get started with the content delivery network in minutes. Amazon's CDN offers a simple pay-as-you-go pricing model with no upfront fees or required long-term contracts, and support for the CDN is included in your existing AWS support subscription. Moving on, we have Amazon Route 53. Amazon Route 53 is a highly available and scalable domain cloud name system, web service or DNS. It is designed to give developers and businesses an extremely reliable and cost-effective way to route end users to internet applications by translating human-readable names such as www.example.com, for example, into the numeric IP addresses such as 192.0.21 that computers use to connect to each other. Amazon Route 53 is fully compliant with IPv6 as well. Amazon Route 53 effectively connects user requests to infrastructure running in AWS, such as EC2 instances, for example, Elastic Load Balancing load balancers, or Amazon S3 buckets, and can also be used to route users to infrastructure outside of AWS. You can use Amazon Route 53 to configure DNS health checks, to route traffic to healthy endpoints, or to independently monitor the health of your applications and its endpoints. Amazon Route 53 traffic flow makes it easy for you to manage traffic, of which can be combined with AWS failover in order to enable a variety of low latency, fault tolerant architectures. Using Amazon Route 53 traffic flows, it comes with simple visual editor, and you can easily manage how your end users are routed through your application's endpoints, whether in a single AWS region or distributed around the globe. It also offers domain name registration, so you can purchase and manage domain names directly at Amazon Route 53, and it will automatically configure DNS settings for your domains. Next one, we have AWS Private Link, which basically simplifies the security of data shared with cloud-based applications by eliminating the exposure of data to the public internet. AWS Private Link provides private connectivity between VPCs, AWS services, and on-premises applications securely on the Amazon network. AWS Private Link makes it easy to connect services across different accounts and VPCs to significantly simplify the network architecture. Last but not least, AWS Direct Connect makes it easy to establish a dedicated network connection for your premises to AWS. Using AWS Direct Connect, you can establish private connectivity between AWS and your data center, office, or co-location environment, which in many cases can reduce your network costs, increase bandwidth throughput, and provide a lot more consistent network experience than internet-based connections. Now, there are many more networking and content delivery services in AWS, and if you are interested in more, you can always check the AWS portal and read about all of them. This will conclude the introduction to networking and content delivery services in AWS. I would like to thank you for your time, and I'm looking forward to seeing you in the next video. In this lesson, we will talk about core AWS services regarding computing. As mentioned in the previous lessons, we will describe Amazon EC2, Amazon Elastic Container Services, Amazon Lightsail, AWS Elastic Beanstalk, and AWS Lambda. First, we will start with the most essential compute service that is available in AWS and most commonly used when starting your AWS cloud journey, and that is EC2. So, Amazon Elastic Compute Cloud, or Amazon EC2, is a web service that provides secure, resizable compute capacity in the cloud. It is designed to make web-scale computing easier for developers. The Amazon EC2 Simple Web Service Interface allows you to obtain and configure capacity with minimal friction. It provides you with complete control of your computing resources and lets you run on Amazon's proven computing environment. Amazon EC2 reduces the time required to obtain and boot new server instances, also called Amazon EC2 instances, to minutes, allowing you to quickly scale capacity both up and down as your computing requirements change. You can, of course, spin up both Linux and Windows EC2 instances. AWS supports huge variety of distributions. Amazon EC2 changes the economics of computing by allowing you to pay only for the capacity that you actually use. Amazon EC2 provides developers and system administrators with the tools to build failure resilient applications and isolate themselves from commonly failure scenarios. Amazon EC2 passes on to you the financial benefits of Amazon Scale. You pay a very low rate for the compute capacity you actually consume. And there are three types of instances on the AWS that you should know. First one is on-demand instances. So with on-demand instances, you pay for compute capacity by the hour with no long-term commitments. You can increase or decrease your compute capacity depending on the demands of your application and only pay the specified hourly rate for the instances you use. The use of on-demand instances frees you from the costs and complexities of planning, purchasing, and maintaining hardware and transforms what are commonly large fixed costs into much smaller variable costs. On-demand instances also remove the need to buy safety net capacity to handle periodic traffic spikes. Then we have reserved instances. Reserved instances provide you with a significant discount of up to 75% compared to on-demand instances pricing. You have the flexibility to change families, operating system types, and tenancies while benefiting from reserved instance pricing when you use convertible reserved instances. Last one is spot instances. Spot instances are available at up to 90% discount compared to on-demand prices and let you take advantages of unused EC2 capacity in the AWS cloud. You can significantly reduce the cost of running your applications, grow your application's compute capacity and throughput for the same budget, and enable new types of cloud computing applications. So that would be it about EC2. Next service we will talk about is Amazon Elastic Container Service, or Amazon ECS. It is a highly scalable, high-performance container orchestration service that supports Docker containers and allows you to easily run and scale containerized applications on AWS. Amazon ECS eliminates the need for you to install and operate your own container orchestration software and manage and scale cluster of virtual machines or schedule containers on those virtual machines. Then we have Amazon Lightsail. Amazon Lightsail is designed to be the easiest way to launch and manage a virtual private server with AWS, so a VPS. Light sale plans include everything you need to jumpstart your project. So it includes a virtual machine, SSD-based storage, data transfer, DNS management, and a static IP address for a low predictable price. One of the services we will also mention is AWS Elastic Beanstalk, which we mentioned in previous lessons. It is an easy way for deploying and scaling web applications and services developed with many languages such as Java, .NET, PHP, Node.js, Python, Ruby, Go, and it is also familiar servers such as Apache, Nginx, and IIS for Windows. You can simply upload your code, and AWS Elastic Beanstalk automatically handles deployment from capacity provisioning, load balancing, and auto-scaling to application health monitoring. At the same time, you regain full control over the AWS resources powering your application, and you can access the underlying resources at any time. Another interesting service that AWS has to offer in the compute services section is called AWS Lambda. So AWS Lambda lets you run code without provisioning or managing servers at all. So you pay only for the compute time you consume. There is no charge when your code is not running. With AWS Lambda, you can run code for virtually any type of application or backend service, all with zero administration. Just upload your code, and Lambda takes care of everything required to run and scale your code with high availability. You can set up your code to automatically trigger from other AWS services, or you can call it directly from any web or mobile application. Later on in the demo, we'll create our first EC2 Linux instance and see how easy it is to connect to it and start working. This will conclude the lesson on computing services in AWS. I would like to thank you for your time, and I'm looking forward to seeing you in the next video. In this lesson, we will talk about core AWS services regarding storage. So AWS offers a lot of services in this section, but we will focus on Amazon S3, Amazon Elastic Block Store or EBS, Amazon Elastic File System or EFS, and Amazon S3 Glacier, and explain every one of them. So Amazon Simple Storage Service or Amazon S3 is an object storage service that offers industry-leading scalability, data availability, security, and performance. This means customers of all sizes and industries can use it to store and protect virtually any amount of data for a range of use cases such as websites, mobile applications, backup and restore, archive, enterprise applications, IoT devices, and also big data analytics. So Amazon S3 provides easy-to-use management features, so you can organize your data and configure finely tuned access controls to meet your specific business, organizational, and compliance requirements. Amazon S3 is designed for 11 nines of durability and stores data for millions of applications for companies all around the world. Next service that we'll talk is Elastic Block Store or Amazon EBS. It provides persistent block storage volume for use with Amazon EC2 instances in the AWS Cloud. Each Amazon EBS volume is automatically replicated within its availability zone to protect you from component failures, offering high availability and durability. Amazon EBS volumes offer the consistent and low latency performance that is needed to run your workloads. With Amazon EBS, you can scale your usage up or down within minutes, and all while paying a low price for only what you provision. Next one is Amazon Elastic File System or EFS. And it basically provides a simple, scalable Elastic file system for Linux-based workloads for use with AWS Cloud services and on-premise resources as well. It is built to scale on demand to virtually petabytes without disrupting applications, growing and shrinking automatically as you add and remove files. So the applications have the storage they need when they need it. It is designed to provide massively parallel shared access to thousands of Amazon EC2 instances, enabling your applications to achieve high levels of aggregate throughput and IOPS with consistent low latencies. Amazon EFS, it is of course a fully managed service that requires no changes to your existing applications and tools, providing access through a standard file system interface for seamless integration. Amazon EFS is a regional service storing data within and across multiple availability zones for high availability and durability. You can access your file systems across AZs and regions and share files between thousands of Amazon EC2 instances and on-premises servers via either AWS Connect or AWS VPN, for example. And in the end, we will also mention one important service, and that is Amazon S3 Glacier. That is a secure, durable, and extremely low-cost storage service for data archiving and long-term backup. It is designed to deliver 11 nines of durability as well, and provides comprehensive security and compliance capabilities that can help meet even the most stringent regulatory requirements. Amazon S3 Glacier provides query in place functionality, allowing you to run powerful analytics directly on your archive data at rest. You can store data for as low as $0.4 per gigabyte per month, and significant savings compared to on-premises solution that's definitely cheaper. To keep costs low yet suitable for varying retrieval needs, Amazon S3 Glacier provides you three options for access to archives, varying from a few minutes to several hours. Later on in the demo, we will create our first S3 storage bucket and see how easy it is to access it and upload a file. This will conclude the introduction on storage services in AWS. I would like to thank you for your time, and I'm looking forward to seeing you in the next video. In this lesson, we will talk about core AWS services regarding databases. AWS has many database services, but we will mention top three services, which is Amazon Aurora, Amazon RDS, and Amazon DynamoDB. To start off, Amazon Aurora is a MySQL and PostgreSQL compatible relational database engine that combines the speed and availability of high-end commercial databases with the simplicity and cost-effectiveness of open-source databases. Amazon Aurora is up to 5 times faster than standard MySQL databases and 3 times faster than standard PostgreSQL databases. It provides the security, availability, and reliability of commercial databases at 1/10 of the cost. Amazon Aurora is fully managed by Amazon Relational Database Service, or RDS, which automates time-consuming administration tasks like hardware provisioning, database setup, patching, and backups. Amazon Aurora features a distributed, fault-tolerant, self-healing storage system that auto-scales up to 64 terabits per database instance. It delivers high performance and availability with up to 15 low-latency read replicas, point-in-time recovery, continuous backup to Amazon S3, and replication across 3 availability zones. Then we have Amazon Relational Database Service, or Amazon RDS. Amazon RDS makes it easy to set up, operate, and scale a relational database in the cloud. It provides cost-efficient and resizable capacity while automating time-consuming administration tasks such as hardware provisioning, database setup, patching, and backups. It frees you to focus on your application, so you can give them the fast performance, high availability, security, and compatibility they need. Amazon RDS is available on several database instance types, for example, optimized for memory, performance, or I/O, input/output, and provides you with 6 familiar database engines to choose from, including Amazon Aurora, PostgreSQL, MySQL, Maria database, Oracle database, and SQL Server. And you can use the AWS database migration service, so you can easily migrate or replicate your existing databases to Amazon RDS. Last one, we have Amazon DynamoDB. That is a key value and document database that delivers single-digit millisecond performance at any scale. It is a fully managed, multi-region, multi-master database with built-in security, backup and restore, and in-memory caching for internet-scale applications. DynamoDB can handle more than 10 trillion requests per day and supports peaks of more than 20 million requests per second. Many of the world's fastest growing businesses, such as Lyft, Airbnb, for example, as well as enterprises such as Samsung, Toyota, and Capital One, all depend on the scale and performance of DynamoDB to support their mission-critical workloads. Later on in the demo, we'll create our first database using RDS, and this will conclude the introduction on database services in AWS. I would like to thank you for your time, and I'm looking forward to seeing you in the next video. In this lesson, we'll briefly mention core AWS services regarding management and governance. 3 major services that we will mention are Amazon CloudWatch, AWS CloudTrail, and AWS CloudFormation. So Amazon CloudWatch is a monitoring and management service built for developers, system operators, site reliability engineers, and IT managers. CloudWatch provides you with data and actionable insights to monitor your applications, understand and respond to system-wide performance changes, optimize resource utilization, and get a unified view of operational health. CloudWatch connects monitoring and operational data in the form of logs, metrics, and events, providing you with a unified view of AWS resources, applications, and services that you run on AWS, and on-premise servers, of course, as well. You can use CloudWatch to set high resolution alarms, visualize logs and metrics side by side, take automated actions, troubleshoot issues, and discover insights to optimize your applications and ensure that they are running smoothly. Next on the menu, we have AWS CloudTrail. It is a web service that records AWS API calls for your account and delivers log files to you. The recorded information includes the identity of the API caller, the time of the API call, the source IP address of the API caller, request parameters, as well as the response elements returned by the AWS service itself. With CloudTrail, you can get a history of AWS API calls for your account, including AWS API calls made using the AWS Management Console, AWS SDKs, command line tools, and higher level AWS services, for example, AWS CloudFormation. The AWS API call history that is produced by AWS CloudTrail enables security analysis, resource chain tracking, and compliance auditing. Last thing we'll mention in this lesson is AWS CloudFormation, and it basically gives developers and system administrators an easy way to create and manage a collection of related AWS resources, provisioning and updating them in an orderly and predictable fashion. You can use the AWS CloudFormation sample templates, or you can create your own template to describe your AWS resources and any associated dependencies or runtime parameters required to run your application. basically don't need to figure out the order for provisioning AWS services or the subtleties of making those dependencies work. CloudFormation takes care of this for you. After the AWS resources are deployed, you can modify and update them in a controlled and predictable way. In effect, applying version control to AWS infrastructure the same way you would do with your software, for example. And you can also visualize your templates as diagrams and edit them using pretty intuitive drag and drop interface with the AWS CloudFormation Designer. This will conclude the introduction to AWS management and governance services. I would like to thank you for your time, and I'm looking forward to seeing you in the next video.
In this lesson, we will talk about AWS technology support resources. If you ever hit a wall when architecting and designing AWS solutions, it's good to know that there are resources that you can turn to for about potential suggestions and solutions. The resources available to you for technical support depend on your support plan. They are developer support, business support, and enterprise support. Developer support is recommended if you are experimenting or testing in AWS. Business support is recommended if you have production workloads in AWS, while enterprise support is recommended if you have business and or mission critical workloads in AWS. If you are on one of these AWS support plans, you can raise a ticket and someone will assist you with your issue. Other than support plans, you also have a few resources available: Technical Account Manager, Trusted Advisor, and AWS White Papers. So, your designated Technical Account Manager, or TAM, is your primary point of contact who provides guidance, architectural review, and ongoing communication to keep you informed and well prepared as you plan, deploy, and proactively optimize your solutions. Some key points regarding TAMs: it's a dedicated voice within AWS to serve as your technical point of contact and advocate. Role is proactive guidance and best practices to help optimize your AWS environment. He also provides orchestration and access to the breadth and depth of technical expertise across the full range of AWS. Next one, we have AWS Trusted Advisor. AWS Trusted Advisor is an online resource that helps you provision your resources following best practices and improve, basically, to help you reduce cost, increase performance and fault tolerance, and improve security by optimizing your AWS environment. While the 4 core checks are available to all AWS customers, the full power of AWS Trusted Advisor is available with business and enterprise support plans. Features of AWS Trusted Advisor include guidance on getting the optimal performance and availability based on your requirements, opportunities to reduce your monthly spend and retain or increase productivity, and best practices to help increase security. Last one, we have AWS White Papers, which features a comprehensive list of technical AWS white papers covering topics such as architecture, security, and economics. These white papers have been authored by the AWS team, independent analysts, or the AWS community, either customers or partners. This will conclude the introduction, brief one on AWS technology support resources. I would like to thank you for your time, and I'm looking forward to seeing you in the next video. This lesson we shift our focus to describe various pricing models within AWS and compare them. So AWS has been developing cloud technology since the early days. Their user base has given us the advantage of having economic of scale. Last year,
Gartner estimated that AWS had 5 times the cloud capacity of its nearest 12 competitors combined. The AWS pricing philosophy is driven by a virtuous cycle. The already low AWS prices reduce the barrier to entry for customers, which means more customers take advantage of AWS, further driving down the costs, and we can see on the image how that basically works. AWS offers you a pay-as-you-go approach for pricing for over 160 cloud services. With AWS, you pay only for the individual services you need for as long as you need them and without requiring long-term contracts or complex licensing. AWS pricing is similar to how you pay for utilities like water and electricity. So you only pay for the services you consume, and once you stop using them, there are no additional costs or termination fees. AWS offers on-demand, pay-as-you-go, and reservation-based payment models, enabling you to obtain the best return on your investments for each specific use case. AWS services do not have complex dependencies or licensing requirements, so you can get exactly what you need to build innovative, cost-effective solutions using the latest technology. There are 3 fundamental drivers of cost with AWS, and that's compute, storage, and outbound data transfer. These characteristics vary somewhat depending on the AWS product and pricing model you choose. In most cases, there is no charge for inbound data transfer or for data transfer between other AWS services within the same region. Outbound data transfer is aggregated across services and then charged at the outbound data transfer rate. For compute resources, you pay hourly from the time you launch a resource until the time you terminate it, unless you have made a reservation for which the cost is agreed upon beforehand. For data storage and transfer, you typically pay per gigabyte. Now, some AWS products are available through multiple pricing models that give you the flexibility to acquire services in a way that best fits your needs. For example, we will take a pricing model for EC2 instances, and there you have on-demand instances. With on-demand instances, you pay for compute capacity by the hour, with no minimum commitments required. Then you have dedicated instances run in a virtual private cloud on hardware that's dedicated to a single customer. Reserved instances, those are for longer term savings. You can purchase in advance, in addition to providing a significant discount, which could be up to 60% with reserved instances compared to on-demand instance pricing. Reserved instances allow you to reserve capacity. And we have also spot instances. You can bid for basically the unused Amazon Elastic Compute Cloud capacity, and instances are charged the spot price, which is set by Amazon EC2, and it usually fluctuates depending on supply and demand. Pricing is tiered for storage and data transfer. The more you use, the less you pay per gigabyte. Volume discounts are also available. Next service I will talk about is AWS Lambda. AWS Lambda, as mentioned previously, lets you run code without provisioning or managing any servers. So with AWS Lambda, you pay only for what you use. You are charged based on the number of requests for your functions and the time it takes for your code to execute. Lambda registers a request each time it starts executing in response to an event notification or invoke call, including test invokes from the console. You're charged for the total number of requests across all your functions. Duration is calculated from the time your code begins executing until it returns or otherwise terminates, rounded up to the nearest 100 milliseconds. The price, of course, depends on the amount of memory you allocate to your function as well. Next one, we'll mention Amazon Simple Storage Service, or Amazon S3, that we mentioned in previous lessons, which is object storage built to store and retrieve virtually any amount of data from anywhere, either that be websites, mobile apps, corporate applications, and data from IoT sensors or devices. As with other AWS services, Amazon S3 provides the simplicity and cost effectiveness of pay-as-you-go pricing. With Amazon S3, you pay only for the storage you use, with no minimum fee. Prices are based on the location of your Amazon S3 bucket. When you begin to estimate the cost of Amazon S3, you should consider the following. Storage class, that can be standard infrequent access for storing less frequently accessed data, and Amazon S3 Glacier storage for archiving data at very low costs. Then we have storage. Costs vary with number and size of objects stored in your Amazon S3 buckets, as well as type of storage that you choose. Storage costs also vary with requests. So the number and type of requests, GET requests incur charges at a different rates than the other requests. For example, put and copy requests. And last, storage costs vary with number of data transfers as well. So the amount of data transferred out of the Amazon S3 region. Last service we'll mention pricing model 4 is Amazon Elastic Block Store, or EBS for short, which provides block level storage volumes for use with Amazon EC2 instances. Pricing for EBS depends basically on three factors. Volumes, so volume storage for all EBS volume types is charged by the amount of gigabytes you provision every month until you release the storage. You can have both SSD and HDD backed volumes. Pricing also varies on snapshots. Snapshot storage is based on the amount of space your data actually consumes in Amazon S3. And we also have data transfer costs. So consider the amount of data transferred out of your application. Inbound data transfer is free, and outbound data transfer is the one that gets charged and is tiered. For all other services and their pricing models, you can always check AWS website and find out more about how each service is built. This will conclude the introduction on pricing models in AWS. I would like to thank you for your time, and I'm looking forward to seeing you in the next video.
In this brief lesson, we will talk about the various account structures in relation to AWS billing and pricing. So moving on, accounts act as a main billing entity for AWS resources. Different billing options are available, including invoicing, such as consolidated billing. That means letting one account pick up the bill for multiple sub-accounts. With regarding to billing, we can set up billing alerts, AWS budget, and automated bill reporting for better insights. We can also utilize tagging for better cost allocation. Now we have different AWS account structures. First, it's a business unit or BU account infrastructure. This account structure can be beneficial for customers who want to align their AWS operational and billing controls with individual business units. It offers individual units operational autonomy while providing a company with a consolidated bill and combined view of all AWS charges separated by group, organizational unit, or cost center. Next one, we have environment lifecycle account structure. This account structure can be beneficial for customers who want to align their AWS operational and billing controls with their application development lifecycle. It offers development lifecycle, operational autonomy, while providing a company with a consolidated bill and combined view of all AWS charges separated by development environment. Next one, we have project-based account structures. So this account structure can be beneficial for customers who want to align their AWS operational and billing controls by product, application workload, or program. It offers projects or workload operational autonomy while providing the company with a consolidated bill and combined view of all AWS charges separated by projects. This structure also simplifies the ability to trigger cost alerts based on project, application workload, or program consumption on AWS resources. And last one, we have hybrid AWS account structures. The basic account structure described previously work for most small companies. However, some large AWS customers find it advantageous to create hybrid combinations that group accounts by multiple dimensions. You can also use the consolidated billing feature in AWS organizations to consolidate payment for multiple AWS accounts. And with consolidated billing, you can see a combined view of AWS charges incurred by all of your accounts. You also can get a cost report for each member account that is associated with your master account. Consolidated billing is offered at no additional charge. Other than that, resource tagging can help track expenses throughout the model. Some of the tags that can be useful for your business are owner, and it's used to identify who is responsible for the resource. Then you have cost center / business unit. It is used to identify the cost center or business unit associated with the resource. Typically, that is for cost allocation and tracking. Then we have customer. It is used to identify a specific client that is a particular group of resources that it serves. And we can also use project, and it's used to identify the projects the resource supports. So customers can activate an AWS generated created by tag that is automatically applied for cost allocation purposes, and that is to help account for resources that might otherwise go uncategorized. The created by tag is available for supported AWS services and resources only, and its value contains data associated with specific API or console events. This will conclude the section on various account structures in relation to AWS billing and pricing. I would like to thank you for your time, and I'm looking forward to seeing you in the next video. In this lesson, we will talk about resources available for billing support in AWS. The quickest way to find the answers to questions about where to bill might be to start with AWS Knowledge Center. In addition, all AWS account owners have access to account and billing support free of charge. Only personalized technical support requires a support plan. It is also worthwhile to know that the AWS cost calculator can be used to provide an estimate for a monthly bill. Also, Trusted Advisor can help with reducing costs by suggesting changes to your existing infrastructure. This section guides you through contacting AWS support and opening a support case for your billing inquiry, which is the fastest and most direct method for communicating with AWS support. AWS support unfortunately does not publish a direct phone number for reaching a support representative. Contacting AWS support can be done by following steps. You should sign in and navigate to the AWS Support Center, and if prompted, type the email address and password for your account. Then you should choose Open a New Case, and on the Open a New Case page, select Account and Billing Support and fill in the required fields on the form. After you complete the form, you can choose web for an email response from AWS, or phone to request a basic telephone call from an AWS support representative. Instant messaging support is unfortunately, again, not available for billing inquiries. Next, we should mention also support concierge as well. It is included as a part of just the enterprise support plan, and the support concierge is a billing and account expert who provides quick and efficient analysis and assistance. Your assigned concierge addresses all non-technical billing and account level inquiries, freeing up your time to run your business. Some features regarding support concierge are he serves as a primary contact to help manage AWS billing and account level services, provides proactive guidance and best practices for billing allocation, consolidation of accounts, and root level account security. It also provides direct access to a billing advocate for payment inquiries, cost reports, service limits, and bulk purchases. This will conclude the section on billing support resources in AWS. I would like to thank you for your time.